Hey folks, welcome to my channel. This is Jackie Chan, and today I'm going to demonstrate you one of my little project, which is uh, if an intelligent battery management system, and it can do a lot of chemistries like nickel cadmium, nickel metal hydride, lithium ion polymers, and nickel ferric, lithium ferric, and all these kind of various chemistries. Now, what was the motivation behind this project? The motivation was my hobby, which is photography. So I have this nice little flash, camera flash from Canon, and it's a speed light. I think it's EX430 or something like that, and that uses 4 cells, 1.5 volt cells. And the moment you throw those inside, you could see like it just makes like maybe 50 pictures, and after that the flash just stops working because the batteries are drained. So then I moved on to putting, let me show you. So then I moved on to putting these nice little cells from Sony. And these are the rechargeable Sony rechargeable cells, and I don't know if it can focus. Doesn't focus well, but okay, let me see. Okay, there it goes. Okay, so it's focusing on my face. Okay, so this is it. So this is the Sony rechargeable cell, and it's like 2000 milliampere hour. I guess it must be 2000 milliampere, something like that. So these batteries are, they take, and this is now, this chemistry here is nickel metal hydride, NiMH, nickel metal hydride. So this needs a different kind of charger. You can't just throw it into a normal nickel cadmium charger and then hope that it charges. So what happens is this has a different chemistry, but it has a long life. So the charger that I got with the Sony for these batteries takes around like 14 hours to charge the battery. And 14 hours is a long time. So you just make some 50-60 pictures, and then you have to wait for 14 and a half hours before you can see the battery. So then I started thinking, why can't we do something that is fast? So I have seen chargers in the market, like they do fast charging nickel cadmium lithium ion cells, or they even do nickel metal hydride. But they're all like, some of them are like discrete boxes, and some of them have some integrated uh, charging mechanisms. But then the features that I was looking for, like being able to measure the internal resistance of the battery, was missing in most of them, and the ones that have them are way too expensive. Secondly, I was looking also for a way to grab the data of the charger, and then you can make a nice little plot and then see how the battery is behaving, how the life of the battery is going. So given all these situations, I thought, maybe why don't I just sit here and design my own box. So this whole exercise took me close to a year. I spent a year. The reason being that I didn't have all the time in the world. I have a day job, so this is just like goes in a part-time project, and then I just do for half an hour or something like that, and then again I come back, again I do that. And um, unlike other projects or other products that you normally see, this product is almost almost it has an automotive grade electronics on it, and do whatever you want. It's it's kind of, you could say that the hardware is almost unbreakable. Is almost unbreakable unless you just take it and put it up into 220 volts and then it's dead. But other than that, if you short the outputs, you connect the batteries wrongly, reverse polarize the battery, do something, reverse polarity the input power, and nothing will happen. Okay, so let me show you some of the features, and if you like it, I can put it up. I can put up the schematics, and also I can share the software. Or if you are not the DIY kind of person, I could also build you one and send it to you. Hey, so folks, this is my little battery charger and battery management system, and this is the box in itself. And this has been the box has been designed using FreeCAD, and I just sat there and drew up the whole box. This thing has been printed out in 3D using a 3D printer, and then it's just been spray painted. So on this side here you have the power input, so you can feed it up to 15 volts of power. And this connector here is the temperature sensor, which is used to sense the battery temperature and limit the charging. This side are your battery terminal inputs. The red is the positive, this is the negative, and here is the RS-232 for communicating with your PC and grabbing out the various data from the charger. You may be wondering what's in this box. It's very simple. So I just open up the box, and that's it. So this is all there is in this box. So here on this side, you can see this is the input voltage and the regulation circuitry. And here, let me just go. Here are your switches for the inputs. And below here, this and this that I see there below. This inductor, this resist, these two transistors, all these together forms a buck boost regulator. So basically it will just take 12 volts, and then you can either increase it up to 15 volts, or it can buck it down up to 1 volt or 0.5 volts. Okay, and this side here is the current measurement that's happening through the battery. Whatever current is being pumped, that is being measured. On top of this, here somewhere just below this this LCD here, if you can see my finger where it's pointing just below, that circuitry is the one that does the RS-232 communications. And this circuitry here on top, this IC, is for discharging the battery and conditioning it, reconditioning the battery in case it needs to be done. And I don't know if you can see just below in here somewhere, hang on, let me just turn on the flash. So inside here is the microcontroller. Just inside is the microcontroller. That's it, pretty much. Nothing so big in here. And in case you're wondering, the PCB has also been designed by me, and I designed the PCB for this. And you can still see the LCD still has the cover on it. It's a brand new LCD, and I still didn't remove the cover on it. And then here is the outputs to the battery, and also there is a fuse here, which is an electronic fuse, and in case there is a short circuit, then this fuse just trips, and after 10 minutes it will reset. Not even 10, maybe 1 or 2 minutes, it will reset itself, and the whole process can continue. So like I told you folks, that this hardware is capable of a lot of things. Okay, so here is the various chemistries that you can select, like nickel cadmium, nickel metal hydride, seal lead acid, lithium ion polymer, lithium ion, and any battery combination you can select. So for example, let's say we want to select a lithium ion. Okay, now just press enter, and then you have various modes, like you can charge them, you can discharge the batteries, you can cycle them, like charge and discharge. So this is good for recovering nickel metal hydride cells. You can recover the battery or you can also do discharge and charge. So you have two cycles, and you can measure the internal resistance. This is something which I have been missing from a lot of even professional grade charging systems. Okay, so this has got this. Then you could also independently measure the battery voltage. Just a quick check you could do on this. And anyway, this is just the info, so it is just like a version number. It will just give you the hardware and software. So this is just pretty fresh software, yeah. So it's just been done 2-3 days ago. With me, I have this lithium-ion cell from a laptop. So I just took this off. It's a 3.7 volt cell, 7.4 watt hour. So this is 18650 is a standard cell. In principle, you could charge it with a 2 ampere current. Is like fast charging, 2 amperes, and you're good. But the problem is these are quite old cells, being ripped off from a laptop. So if I'm putting 2 amperes into this cell, it goes way too hot, and so I've been charging them with a lower current, but like with a 1 amp current, and then it just charges good. I have finally connected the battery here. So I've taken the negative and the positive of the battery and connected it up to this charger. And now I'm going to connect, let's say, these wires here. So we are measuring 3.107 volts on this, and here we are measuring on my multimeter, I'm measuring 3.177. So we have a 70 millivolts difference between these two. There's a special mode where you can just go in and you can calibrate this charger so that it gives you accuracies up to 10 millivolts. So it's accurate to 10 millivolts for voltage measurements, and it's accurate to 20 milliampere for current measurements. So, but as of now, I leave it as it is. If you are not satisfied, you could always go in and recalibrate. Okay, so let's measure the internal resistance of this cell. So it's 579 milliohms, which is good. It's very good for this cell. Lithium ion, and let's go down here, and we say here charge. Okay, and then you press the enter, and charge current is always at 1C. So whatever is the value, the charge capacity that you have specified is just 1C for lithium ion. For others, it can be changed. So I would say just go with one cell, and you just say go. That's it, and then it just does a quick check, and then it's now trying to charge. It's measuring the temperature of the battery. On this side, you can see here is the temperature of the battery. It's giving you the chemistry of the battery, and FCC means fast charge with constant current, and this is the battery voltage. This is the current that's being supplied. So as of now, it's supplying 147 milliampere, and this whole current regulation is working with a PID. It's very accurate. It took me a while to tune the whole PID, but now it seems to work flawlessly. Okay. In the meantime, while this is going up, let me just go and show you how to grab the data. So the data is being grabbed, can be grabbed by using a standard RS-232, and there are 3 pins here: RXTX and ground, the usual pins. There is a way to plug this in here. There's a point to plug this in. So just plug this in, and that's it. So now you can see it has already almost reached the 1 ampere that we have set, and the PID is doing a good job. It's holding 999 milliampere. So you can see that now the battery voltage is rising. Okay, so let me show you quickly how the data can be grabbed. Okay, so here I have connected the whole charger. Okay, and you could just connect this here to a standard RS-232, and I have connected it to a USB to serial connector. And from here I will go back to my PC, and what I did was, there is a program called Regulator, and you could just open it up. It's just a serial port monitor. The only good thing is it just creates a log file. Okay, with the log file, what we do is we have a program. It's a freeware, and it's called KST. It's a data viewing program. Okay, and you could download it from kst.org. And I created myself a configuration where you could see here. I have one graph which shows the battery voltage, one graph which shows the battery current, one which shows the temperature and what is happening to the V input voltage, and the PWM charging and discharging PWMs, and then also if there is any fault code it shows you, and then it shows you the charge capacity of the battery, how much power is being charged into the battery, and if you're discharging and cycling the battery, you could also see the discharge capacity. And there are a few more things, but those are not relevant. The only relevant parts are these graphs. So let's go back. Let's say charge, blah blah blah. Okay. Okay. So now you see here. Now you see here. Just watch it. What's doing? So, and you can see here. Let me see. See, this is what is the data it's grabbing. So it's 3240 volts, and you can see here it's 3.2, and the current is at 140 milliampere, 159. So it's ramping up the current, so it's going up. So you can see here how the battery current is ramping up. So it's going to 300 milliampere, 400, 500, and you can see that the VIN is pretty much slightly drooping, and that happens because you're charging the battery, so the power supply will generally droop a little, but that's how it works. And as of now, there is no charge capacity, no faults, zero, and the PWM is ramping up and up and up, and then it became steady at some point, and now you can see here that it has reached 1000 milliampere. Okay, there you go. So see here, it's holding the current to 1000 milliampere. So, and that's exactly what you see here. It's holding it to 1000 milliampere. And the voltage is slowly rising. And once the battery reaches the voltage, then it will switch into constant voltage mode. So I hope you liked my video. I tried to demonstrate my little battery management system. If you like it, just share your comments. Even if you don't like it, share your thoughts or comments, and subscribe to my channel. Thank you. Thanks for watching.